I have to step out here where I can kind of see this out of the corner of my eye. One thing that we wanted to point out, and we'll show you the website in a minute, you guys know how to get to Best Ink, I hope. If you don't, that's the first thing you need to figure out when you get back to school tomorrow, is how to get to Best Ink. There is a lot of information saved out there. You can see other schools' engineering notebooks that they have posted for you to view. They're not trying to hide them from anybody. They want you to be able to see theirs, and then they hope that you will post yours so that they can learn from what you do as well. Also out there, as you get into the design and build of your robot, there's a lot of information out there about how the controllers work, how to build components of the robot. So this will be a very, very good resource for you. And I usually get to it just by going to bestink.org. But Stephanie, that's the one that most of the time you'll see posted. Okay, first thing we wanted to do is tell you what we're going to use to evaluate. And that's the presentation, and in a little while we'll give you a copy of the score sheet that we used last year. It may be revised a bit this year. Some of the scoring that Best is going to use at Big Best is going to change, so we want to change ours so that we are grading you on the same criteria that they will if you go to Auburn. First thing that we want to see is, how did you implement the engineering process? How did you make the decision to build your robot the way that you did? What things did you find that didn't work? You know, don't give us an engineering notebook that says we built it, we ran it, we won. Because we know that someplace along the line something didn't work that you tried. And we want you to document that, because you learn from that. 35 years in the engineering profession, and I'm still learning. So that's one thing, no matter what profession you go into, if you don't learn something new every day, it might be time for a career change. Because there's always something new for you to learn. Okay, whoops, wrong button. The research paper. You'll have an opportunity to research the, Seth, what's the right word? Well, the game, but the
theme
process,
of the game.
the theme of the game, and why is that important for us? Why is it a problem that we need to solve? You know, we've had a couple of, I like bugs. That was, I think, of all the ones we've had, that was my favorite. You know, you've got these little critters that you need to get rid of. How are you going to do it? What were the things that you considered trying? What worked and what didn't? Your research paper can probably help you avoid some pitfalls. When you start to research what's going on, you'll probably find that you're going to make some changes either in your robot or in the way that you're going to try to play the game. So the research paper is pretty important to you. Brainstorming approaches. We've got another class I think we'll do in the fall on brainstorming itself. Brainstorming is just a way to generate a lot of ideas. The more ideas you have, the more choices you have as you're going to build your robot. So we want you to learn how to brainstorm. It's important in industry for you to be able to find unique ways to solve problems, and that's one of the things that brainstorming helps you do. We want to see your analytical evaluation of the alternatives. If you had 3 alternatives, why did you choose the one that you did? Maybe it was the cutest robot. Maybe it was the easiest robot to build. Maybe it was the robot that you felt could perform a task that would generate the most points for you during the game. But what was the reasoning that you used for selecting the design that you did? Offensive and defensive evaluations. When you look at the game, you're going to see that offensive would be things that you do to score points, and bugs, it's how many bugs did you capture. Defensive could be things like you used a piece that your neighbor wanted to use, but you got to it first, and you used it first. So what are the offensive and defensive things that went into your strategy for playing the game? Safety. Safety is very, very important to us. We want you guys to go home with all the fingers and toes that you came with. Okay? So we want to see how you are incorporating safety into your robot design and build. You know, what are you going to do in each of your meetings or each of the sessions where you're building your robot? What's the protective equipment that you're going to require your players to use? How did you evaluate what was safe and what wasn't? Okay. Supporting documentation. That can be anything that you used in the process of designing your robot. It could be something that you looked up on Google. It could be something that you looked up at the library in the encyclopedia. Anything at all that you used. Calculations. I'd kind of like to see more calculations in our engineering notebooks. In the past, we haven't seen a lot of them because your robot's going to have to do things. If it has to lift something, how do you know that the robot's going to be able to lift that 2-pound weight? And you could do some calculations to determine that. The overall quality and completeness of the notebook. All of the criteria that are listed in the evaluation sheet we think are important to the notebook, so we want to see that you've used everything that we're evaluating in the notebook. How complete is it? Is everything 1 or 2 sentences, or do you have a couple of pages on some things? The engineering notebook, there's really not a size requirement. Well,
limit.
There's a limit.
20 pages. Yeah.
But we don't require that it be more than 5 pages. However, the more information you have in there, the more that notebook's going to help you next year. When you get ready, when you start preparing for your 2nd year or 3rd year or 4th year, you can go back to your engineering notebook and look and see what worked and what didn't. Did you have problems keeping the wheels on your robot this year? So is there some design that you need to change in the way that you build the hub for your wheel, or the way that you attach your wheel to the motor? So, you know, those are things that you can use in the future to help you with your robot. Okay. Planning and preparation. With the first thing you have to do is know what the challenge is. What is the game, and how are you going to approach the game? The first thing you need to do is look at your team members. You want team members that will bring a variety of skills to the team. Some may be pretty good at drafting or making sketches. Some may be very good at writing papers. They can help build your engineering notebook. We want you to see that there are opposing options, or opposing opinions. You don't want to argue at every meeting, but it's important to have different ideas on the team, because that's how you identify the different things that you can do, and then as a team identify the best thing. You want team members that can accept criticism without getting mad at you. You know, if their idea doesn't work well, you don't want them getting mad and huffing off. You know, you want them to be a team player, and they need to work with the team. And if their idea doesn't work, they need to support the next idea that you try. It may not work either. You might go back and try a third idea. You want people to participate equally, both as a worker and a leader. You're going to find that people can lead in different areas. So you may have one person that's really good with ideas and generating ideas. They can help you brainstorm. They can help build some of the ideas that you're going to use to build your robot. And then you may have somebody else that's really mechanically inclined. They're real good at building things. You know, they do something on the side. Maybe they built a motor for their truck or something. So you want people that can both lead and work with your team. And then you also want people that can follow the rules. Your team is going to develop a set of ground rules that you're going to use for your meetings, for your design, and you want people that can follow those rules. If you've got a couple of people that just absolutely won't follow the rules, your team's going to be in a turmoil all the time, and you're just not going to make a lot of headway. Okay, every meeting is a part of the process of designing your robot and ultimately competing with your robot. It's important that you document what you do at your meetings. You can videotape them, you can just take notes. Those notes, though, need to become a part of your engineering notebook. So at every meeting, you should put something in your engineering notebook. When you get to the end and you start to really finalize your engineering notebook, you may move some of those things around, you may take some of those things out, but you're not spending time trying to get information to build your notebook. You've already got the information, and all you're trying to do at that point in time is organize it. And you'll find that your notebook is going to be a lot easier to do if you keep that in mind at each meeting. You know, we're going to do something that we can put in our notebook. Meeting minutes are pretty important. You can document in the minutes why you made decisions and what decisions you made. And what that will do for you, if you get into the next meeting, and last meeting you decided your robot's going to be red and why, and the next meeting somebody's arguing to make it blue again, you can go back to the minutes and say, whoa, time out. We already made that decision. And now you can move on to the next thing. If you just keep going back and revisiting and redoing things, you're going to get pretty frustrated, and then you're going to get into a crunch at the end when you're trying to get your robot ready to compete. Keeping ad hoc drawings or sketches as you go, and also any notes that you have, can be pretty important. One of the things that we do score in your engineering notebook is how well have you, how many drawings have you put in there? What kinds of drawings have you put in there? And these initial sketches are really good to see because it gives us an opportunity to see the thought process that you used as you went through and tried to build your robot. So we, the judges, would really like to see that information. We want to know what you did, what worked, and what didn't.
Can I add a 2 cents worth on that? We've seen some with drawings on napkins. If you're sitting at a table somewhere and you're just sketching something, put that in your notebook, you know? Or maybe take a picture of somebody drawing something on a whiteboard, you know, as you're discussing something. Put that in your notebook. So any of that kind of thing can be the, I guess that's supporting documentation more than anything, but because your actual drawings might be more mechanical. But
I was involved in a team several years ago, and we nearly fell apart because the board that we were using was supposed to print what was on it. Well, it quit working. You know, well, what are we going to do? You know, we've got to keep that information. We need it. Well, one guy pulled out his cell phone and we started taking pictures. So we quit printing it. We just started taking pictures of the board before we erased it. So You can do those kinds of things. Okay, the design process, the very first thing you have to do is identify the problem. And make sure when you identify the problem that you identify one problem. You're going to have others that you will identify as you go along, but try to solve one thing at a time. Last year, your robot had to drive and it had to cross a pretty rough path. So you might want to start out trying to figure out how can I make my robot do that. Or if you identify a particular task that you think is the way to make the most points, you might want to concentrate initially on how can I make my robot do that, and then worry about how to make it move later. But you need to solve the problems one at a time. When you start trying to solve 3 or 4 or 5 problems simultaneously, you're going to get all crunched up, and things are going to stop making sense. And then when something doesn't work, you're not real sure why it didn't work, because you made so many changes. You're not sure which change it was that made the robot quit working like you wanted it to. So try to do things systematically. Try to identify and go after one thing at a time. You have to do that pretty quickly, but you won't be going back and repeating things if you do. Okay, you want to develop the specifications and requirements. Specifications are the quantitative values that are provided or inherently known for the problem definition. So some of the specifications that I know you'll have are, this has got to fit in a certain size box. It can't weigh more than a certain amount. So those are specifications for your robot that you have to abide by. If your robot won't fit in my box, you've got to change it. And I didn't make that rule, okay? Requirements are typically statements that will indicate what needs to be accomplished. So the requirements are getting more into what does my robot need to do. Last year, it needed to move the top of the windmill, or it needed to move the blades for a windmill. It needed to be able to cross a rough path. So those would be requirements that the robot needed to do, or requirements that the robot needed to meet to be able to play the game. And then you want to prioritize the specs and the requirements to identify any conflicts. You may line up the specifications and the requirements and find out that maybe with the size fitting into the 3-foot box, 2-foot box, I'm sorry, fitting into the 2-foot box, you've got to be able to reach 4 feet with your robot. That's one of the requirements. Well, the specification says that your robot can't have any part that's more than 2 feet long or that will fit within a 2-foot cube. So you're going to have to look for some unique ways to accomplish both. So those would be the first things you want to attack, are the things where you've got a specification and a requirement that appear to be in disagreement. Okay, then you want to generate some possible designs. One way, and I have found over the years it's a very good way, is to use one of the brainstorming techniques that is out there, and you can find many on the internet. I'm a post-it note kind of guy, so the brainstorming that I like to do is everybody puts their idea on a post-it note, and one by one they go put their post-it note up on the wall. You don't get to discuss any of the post-it notes. None. All you do is put the ideas up there. Later in the process, you're going to come back and evaluate those ideas and try to find the ones that are doable. You know, if one of the ideas is to build the robot out of 24 karat gold, I guarantee you it won't work. for two reasons. You can't afford it, and it'll be too heavy.
It's not in your box either, I can promise you that.
So you know, you want to be able to, but you need all of those ideas, because you may find out that, whoa, making one piece of this robot out of 24 karat gold looks like a really good idea. So you can generate your ideas, get them on the wall, and then come back and evaluate. You always want to try to break big problems into smaller problems so that you can work on things at a lower level. You know, one piece at a time kind of attitude. You don't want to try to solve world hunger all in one fell swoop. Okay, you want to repeat the process as many times as you need to. It could be that you make 8 or 10 iterations with your robot. You know, you find out how you're going to make it move, then you find out how you're going to make it either pick something up or put something where the game says you're supposed to. So then you'll repeat the process. As a group, you want to evaluate each design and determine if there is some change that needs to be made. Could we make it better? If you're in a situation where your robot's maybe running a little bit heavy, you might want to go back and revisit some things like, how are your wheels made? If your wheels are solid, you might be able to cut some holes in your wheels and make them lighter, which then will let you use that weight someplace else on your robot. And eventually your team's going to reach consensus on the design, and you'll be able to move forward and start into the construction. Okay, you want to model and simulate the latest design. You don't want to decide what your wheels are going to look like, decide how your controller is going to work, decide how your robot's going to move, decide how it's going to lift something, build all that, and then sit it on the floor and find out that it won't work. So you need to make models as you go. You know, build your wheels and try them out. Will they roll across the surfaces that they're going to have to roll across? One year, we even had robots with no wheels. So
2 years.
Yeah.
The Space Needle and the trolley.
Yeah. So, you know, you don't want to spend your time working on components that you're also not going to need. But you want to break it down and try to solve all the problems in bite-sized pieces. You want to look for interferences or weak points. If your robot has to lift something, but your arm is made out of one piece of the PVC tubing that we give you, and it won't lift that much weight, and you can try that without building a robot. All you've got to do is take a piece of the tubing, put the weight on it, and lift it with your arm. See if that piece of tubing will support the weight that you're going to need to support. You want to evaluate the design for durability. You don't want to go through 3 or 4 rounds and have your robot in 4 or 5 pieces at the end of the 4th round. So you want to, as you're building your robot, you want to take a look at it and think about, how sturdy is this going to be? How well is it going to perform through the whole competition? You want to compare the design to the criteria that you put together in step 2. Check to see if it's going to fit in that 2 cubic foot box. Check to see if it's going to weigh less than the allowed amount. And then you want to repeat the consensus check with your whole team and get everybody to weigh in that yes, this is the best design. And when I say consensus, that doesn't mean that everybody on the team has changed their mind and now they think this is the only way to design the robot. It's perfectly all right to have people that think that their idea still might be the best, but they bought into the fact that the team has decided this is the way we're going to go, and then you can proceed, and everybody will be helping the team as you go. Now, you've tried out all the individual pieces. You want to build a prototype. You probably won't be able to go from the design to the final product. As you build the prototype, you're going to find interferences. You're going to find things that need to move, but they can't because they're hitting something else that's on your robot. You're going to find that your robot is heavier than you thought it would be. There'll be a lot of things that you learn if you build a prototype. As you're building the prototype, you want to stay true to your design. Don't do your design on the fly. If you're building your prototype and you see one interference, don't stop and try to fix that before you move on with the rest of the build of your robot. If you go ahead and build the rest of your robot, you may find that a fix that you were going to use here creates a bigger problem elsewhere. So it's best to go ahead and get your prototype built and then look to see what all of the issues are and try to solve all of the issues one at a time. Then you would go back to step 3. Now you want to test your robot. You might want to build a part of a field, or you might want to simulate one section of the field as you go. Last year, one team actually built a field and allowed other teams to come practice on it. They got a lot of spirit and sportsmanship points for that. I'll tell you that too. But that's all part of BEST. We want you guys to work together even though you're on different teams, because both teams will do better than if you hadn't talked to one another. So it's very important that you share with the other teams. And sharing failures is as important as sharing successes. And then you want to repeat the test several times to make sure that everybody can support that final design. Is the design that you've come up with going to be robust enough to go through the whole competition? Is the design that you've come up with going to be able to perform enough tasks to get you enough points to win the competition? You know, if your robot's only able to do the lowest point scoring function or activity, you might not be the winner at the end, unless you can do it real fast and a whole lot of times. But those are things that you have to consider. You're going to have to develop a schedule that takes into account all of these activities. So as you're preparing for the season, and you could be doing a schedule today for this fall. You don't know what the game is yet, but you could be laying out a schedule and say, when we've got the field reveal and we know what the game is, we're going to spend 4 days on brainstorming. We're going to spend 2 or 3 days building components to test. We're going to build in the 2nd or 3rd week. We're going to build the prototype. So it's important to get a schedule and then work to your schedule. Now, when I say that, I don't mean that you've got to perform every task when your schedule said you were going to, but you need to be looking at your schedule and try to see, am I ahead of schedule, am I behind schedule, am I on schedule? Because if you start to get way behind schedule, you're going to have to rethink some of the things that you were planning to do. You've got to have the robot done 6 weeks after we tell you what the game is. So that's a hard, fast, we're not going to change that. So your schedule needs to take into account, you know, any milestones that we give you, and those milestones will be pretty much the mall day, which will be the first time that you get to see the field and put your robot on it. You're going to have a deadline for getting your marketing in, your engineering notebook in, and then some other things, right, Stephanie? And
right.
I know I don't.
And there's a short list of dates in the packet that we can hand out to them later. And in the notebook that Sassy, some of you have the 3-ring binder notebook. There's a couple of different called 42 days of best timelines that give you a general thing of this week do this and this and this and this, and this week do this and this and this and this, and it kind of gets you set up to be finished in time to compete. But one of the suggestions I've heard from other hub people and teams is no matter what your other designs are with arms or rotating things or flashing things or whatever, get wheels on the robot and get it moving and get somebody driving it. Because one of the most important things is within a week or two, get a robot moving and somebody driving it to practice driving, because that's the hardest part. A lot of people, they end up not getting their robot moving until the last week or the last, we've had some teams the day or two before the competition, so they have no practice driving. Was that y'all? Okay. They had this little sly look. No, but there have been probably a lot of teams that are that way. But the more practice anybody can have driving, because you have to have multiple drivers, so you have to let multiple people practice. So the quicker you can get it moving, whatever the wheels are on the bar or whatever it is that it's going to be this year, the better, so that they can be practicing the technique of driving.
Mitch, you want to cover a couple of these?
Yeah.
Okay.
Let's take a little pause, and
Rick.
we're about 45 minutes in, and we've got lots more time than we're going to need for this thing. So let's do this. Pause, ask questions on anything that we've covered so far. I'm going to go back and give you the quick, anybody like Cliff Notes, the short story? One real quick, bam. Okay, I'm going to give you the Cliff Notes on some of these slides, go back to them real quick. You may want to jot down actually on the little note section of this thing, some just quick takeaways. But before I do that, what has Mr. Steve covered so far that you have questions on? Who's holding up any? Come on. You must be an excellent
Perfect engineering notebook.
Fill her back to about the first. Let's see if I can get something. And then that's four. Okay. On this slide, I think the takeaway here is how late you are.
Yes, the little green.
Work.
The word I would put beside this slide is diversity. You want diversity on notebook team. That means you need some people that are really good writers. You need some people that are really creative. You want some people that are very analytical. That's what I mean by diversity. We're talking about diversity of thinking. Got me? Because guess what? Probably the one that's analytical, and that's their strong suit, they're probably not going to be the best writer for your research paper. It's just the facts. That's what happens. So make sure that you recruit enough people on your notebook team and design team that you got that kind of diversity. Okay, here's the reality too. If you put a really diverse team together, there are going to be instances where you're going to disagree on how to move forward, and that's okay. And that's the reason it's important to have your ground rules already laid out. And I encourage people, I teach creative classes, and so all the time I encourage people to treat someone else's idea as a newborn baby. Okay, now nobody would go up and tell somebody that their newborn baby was ugly, would they? No, you don't do that. You say, that's such a cute baby. Same thing with ideas. When they're young, they're really fragile. And so all you can do is say, that's a great idea. I wonder what it would look like. And then you can build up the idea. Don't tear it down, particularly in the early stages. There's plenty of room in this process for critique later in the process. So I think that's really important takeaway here is learn to accept some criticism at the right point, but more importantly, don't criticize something too soon. Work through those things. If you don't understand what somebody's talking about with an idea, ask them questions to explain it. Get them to restate it in a different way. I think that's really important, is to get diversity going on. Go ahead on this one, the takeaways are assign roles up front. So somebody needs to be the note taker every time. Someone needs to be the photographer. Have a good cell phone that will take it, or smartphone, or whatever you want to use. Document everything with those images. A couple reasons. One, it's easier to save those things if you've got photographs in your phone that you can upload to some cloud-based thing, like anybody use Dropbox or Google Drive or anything where you can share files. That's a great way. Create you a folder for best. Let everybody have access to it on your team, particularly the notebook team. Put everything. If you draw something out on a note, on a napkin, like Stephanie was saying, just lay it in and take you a photograph of it, upload that to it where everybody can have that. Save everything. Document everything. Take lots of photographs. Take photographs of the thing when it broke and didn't work. That's what people won't do that drives us crazy. That tells us that you're actually using the process, because you tried something and it didn't work and you learned from it and you do another cycle.
Can I tell a great story about that?
You may.
Y'all gonna hate that I'm doing your camera work. I'm not supposed to be talking, and I am. We used to do a program for 8th graders called Bird Inc. This is when y'all probably were gleaming your parents' eyes. And John Cranston, who did this, was a real rocket scientist. And he had a really interesting story. He was a hippie leather belt maker and all this stuff, and he didn't get his degree until he was 50, right? 40, maybe.
He got his PhD when he was 50.
Okay, so he didn't get his college degree until he was 40. He got his PhD when he was 50. But he made a decent living because he knew how to do stuff. So that was kind of his story. And he taught this to 8th graders by demonstration of a factory. But he had multiple patents, real patents for things that he had created and invented. One of them was this foam stuff that was used on the space shuttle. Y'all, I assume y'all still know what the space shuttle is since it just went out of commission. But so he actually created this foam, and he made a mistake in the laboratory. And he documented it because, like Mitch was saying, document everything. So he documented it. The chemicals he was using were very expensive. And he said, had he been kind of dishonest, then he would have just kind of pushed it under the table and not documented it because he didn't want anybody to know he wasted those chemicals. That was the formula that created the foam that he got the patent on, that went on the space shuttle, went into space multiple times. So documenting everything, you may find out, you think it's a problem, you think it's a mistake, but later it may be the thing that works. But you've documented it so you can go back and repeat it. He could repeat it because he documented his process. If he had not have just brushed it under the rug, he wouldn't have known the amounts of chemicals he had used, and he wouldn't have been able to repeat it. So it's real important to document your process.
Happens over and over and over again. Some of the best ones, Post-it notes, little sticky notes. Mistake, the guy was trying to make a really strong adhesive, and he made a real weak adhesive, kind that they put on the back of the Post-it notes now that'll come off from everything. That's the way it works. Telephone, wouldn't have had it if Alexander Graham Bell could read German very well. He was reading a German research paper, and he thought that it said in this paper that you could transmit a sound signal through a copper wire. It wasn't what it said at all, but he went and did it, came back, and that's how he got the telephone, was because of that. So mistakes are not mistakes. They're just opportunities to learn something. That's what I like to say. That's because I mess up a lot too. So I can use that as an excuse on it. Now, the difference, and I think I heard you as I was walking to get my marker, the difference when we talk about consensus building of the team. Does everybody get what that is? Somebody else explain it to me. What's the difference between, okay, just I don't care, and having really consensus on an idea?
You all agree to the idea?
Yeah, and you don't have to agree to every element of it, but you're willing to go along to see what happens. That's the difference. Give people a little bit of leeway, because you don't always know how it'll turn out. And so consensus is that you kind of let people do a little bit more, but then you go back and you have an open discussion, and if it didn't work, you know, you don't criticize. See, don't say, see, I told you that would work. That's not acceptable. What you say is, okay, now that we've done that and that didn't work, did we learn anything that now we can leverage that into a better idea? That's the way you get to consensus on it. It's just a process. Let's see. Let me go to, yes, this one. The takeaway on this one was about the consensus and also the idea of the requirements. You know, in design we call those constraints. And so the best products are ones where you have a clear understanding not only of what you're going to do, but what you're not willing to do. In other words, we've tried before to move our robots in this manner, and that is not going to be our design this year. That's a constraint. You set it up front because you had problems, and it could have been that we used really big wheels, we used really small wheels. We had real big gears, we had real small gears. Okay? And if that's one thing you say, we're just not going to do that, then that's a constraint. Just put it in up front and move on. And that's fine. And sometimes the better, elegant designs come from really documenting not where you think it's going to go, but what you're not willing to do from the onset of the project. So that's an important takeaway. That thought. And I'm going to cover this a little bit after we come back from break, but I did want to talk a little bit about generating possible designs, brainstorming activities. I'm going to give you a few in addition to the one that Steve talked about. One, has anybody heard of what's called mind mapping? You have? Did I talk about it last year?
No, we've done used it.
Okay. That's a really good process. You can Google it, look it up. There's all kind of cool tools you can use. Paper's best. Whiteboard is best. So what you do is you start with something in the center and you say, okay, and to your point, you may break the challenge down into some things. So what you do in the center is we need ideas for increase speed of the robot. Okay? So that's what you're doing. And then you'll come off with some legs, and so you're kind of deconstructing that. And so what might be an element that we would start with if you need to increase the speed of your robot? How could you do that?
Rotation per minute of the wheel.
Okay, so we got wheel rotations. Okay, now, how might we increase wheel rotations?
Bigger wheel. Bigger or smaller wheel?
Smaller wheel, bigger wheel.
Bigger wheel.
Okay, so increase wheel diameter. Right? What else? How else can we do it?
Less weight.
Less weight. Like it. Okay. How else?
More friction.
Huh?
More friction.
Well, if it's a belt drive, that's true. So you have to kind of come off here and put increased friction. And I put in parentheses maybe belt drive. Okay, now, see what I did was that's just one leg. Now, I might come up here on another one and say, it's not about the wheel rotation, it's about maybe the gear ratio. Or it's about the, or you can deconstruct then go in here and do another one, so maybe weight loss goes down there. Or you can come off with, how would we get weight loss? You know, there's lots of ways, right? You could drill holes in a piece of PVC pipe and make it lighter at the expense of what?
Durability.
Right, strength, maybe, or maybe and the lack of strength may lead to durability. So, see quickly, the reason I like this kind of an approach is that the other approach is the way linear people usually think, which is a list, bullet point list. And they don't connect the dots as well as this does, because this, and you do these things not as individuals, but as a team. So it's truly a brainstorming session, but have a board like this, and just like I did, have somebody that's a scribe, and whatever your challenge is, put it in the center, and start off of that with different legs. And you don't need to write large things. Notice that I even used, instead of words, just an up arrow meaning increase, or down arrow to decrease. Just capture the main essence quickly. Those things, 15 minutes of doing this can lead you in some really good directions with it. So that's a really good one, I think, to do. And so this is all part, so you'd come off with different things here. You can have multiple mind maps for different areas of your robot design that you want to do, whether it's about the locomotion of it, how it moves, or whether it's the articulation of the hand. There's usually always something to do with a grip and a hand and control like that. So you can do multiples on this. And then these lead into another aspect of this, which is you just go through cycles of learning, and you're going to fail, you're going to mess up. That's okay. And so I usually use, and this is, some people call it just a scientific method, but it's you plan. In other words, you come up with a hypothesis of what I think this will work, maybe. And then you go out and you do something. That means you build a prototype, or you test something, some test. What's the strength of the material? What happens when we increase the gear ratio? What happens when we decrease the gear ratio? Okay? And then you can study the results of your test. And then, what would you do then? Any guess?
Say whether it worked or didn't.
Or just adjust, or act again. A lot of people call it act, I call it the adjustment phase of it. And then guess what? You do it again. So that's just one cycle. It's a learning cycle. Plan, do, study, adjust. Plan, do, study, adjust. I mean, it just quick, and do them quick. Don't wait a whole week. You ought to run several cycles in a meeting evening. Different people doing different things though, because you don't have enough time to do this linear. It's not like a relay race. Some of you need to be working on one aspect of the problem. Others need to be working on another aspect of the problem. And if you'll do those things, what that's going to do is it'll set you up for success in this, that you'll have more time at the end. Because if you try to do it linearly, it's like a relay race, people handing off, guess what happens? You run out of time. You run out of time.
For the perfectionists in the crowd, it won't be perfect, I can promise you. It will be far from perfect in the 6-week time period.
Let's see, more takeaways. Pen and paper are the cheapest form of prototyping, is what this is saying. Go ahead and draw it out. If you got somebody that's expert in AutoCAD, or one of the, what program?
SolidWorks.
SolidWorks.
Or Inventor.
Or Inventor. Those are fine to use, but guess what? Start with pen and paper and drawings, and do your prototypes that way first. That way you can show somebody else what you're thinking quickly, and they can understand it.
This isn't a marketing presentation, but one of the best marketing presentations I ever saw and judged in Tuscaloosa, they had a whiteboard that, they gave this part of the presentation and that part, talking about their team, their community and all that, and then they started talking about their design, and this girl actually got up there and sketched a 3-dimensional drawing of their robot. They didn't have the CAD drawings that everybody else had, but she sat there on this whiteboard and did this fabulous 3D drawing of their robot. It's like, gee, all within their 20-minute time frame or whatever. It's really cool.
Let's see, that's impressive, I think. This is about, the takeaway here is, go ahead and do a scale model, even if it's not out of the components in your box. Get some cardboard, get some construction paper, use some, whatever you got. tape, wire. Hang something together that's about the size so that you can kind of get an idea about, will things fit together, and not waste your time using the other thing, because it's, you know, waste of time if you, and you'll consume a lot of your resources too of the consumables if you make your first prototypes out of those. Use other things that you've got access to that are cheap. Pretty self-evident on that one. Identify the problem, technical challenges. Again, this is more about the constraints on this, but this is kind of where we transition. So what do we do this? 15-minute break, is that okay?
Sure.
Okay, pause for questions on what I covered before the break. And that was just the clip notes of what we'd already gone over. If no questions, I'm going to ask you what you learned. You got to talk to them. You're going to have to eliminate. What did you learn with what I covered earlier? What Steve covered earlier? Key takeaway points. Something that you didn't know when you came in here.
Supposed to mark down your failures.
Yes. This is not a question documentation. This is a learning documentation. But the student said that they learned to document failures in additions to what went right. What else? I'm not going to let you get away that easy. You got somebody else. What did you learn? We didn't learn anything. We're a failure.
Yeah.
We are failures.
Okay, start over. Start the whole class over.
Yeah. I bet I'll get them to say something.
Yeah.
Come on.
We've learned everything, so we need nothing.
It's all.
Learn everything. Everything there is to know. Okay. You can still ask questions now. You know, we won't even, remember I said I don't criticize. That's not part of this. So even the question's not going to criticize. It's all good. So an important aspect is identifying the problem, putting those constraints around it. It could be design constraints. What are some other constraints here? What are we talking about here? Does anybody get this reference? What is a carbon-based life form? Anybody Star Trek fans? So maybe. What is it? What is a carbon-based life form? What is it?
Ron knows it. Yeah,
He does.
don't know it.
You know it, don't you?
Is it like an actual person?
Yes, a human is a carbon-based life form. Why do you think we say humans are constraints?
Because we're limited.
That's exactly right. Any individual is. And so know what your strengths are, know what your weaknesses are too. So that's the reason that diversity on your team is important. If you got, you know, some constraints in your carbon-based life forms, add people to it, add more. Several of you will get around that constraint. Physical and quantitative material resource constraints. You know, you've got only things in the kits that you can use, and so those are constraints in their own right. And so you've got to evaluate that. The biggest one, I think, time constraint. It'll go very, very fast. Tell me what your experience, those of you that have gone through this before, several of you have, almost all of you. Is that true? That one of the biggest constraints is a time constraint? What do you plan to do differently about it now that you know that? Start earlier. What else?
Manage your time.
How are you going to manage time better? It's not, that's a good answer, but I'm digging. I'm asking why 5
Get your
hours.
people like on the timeline, like when you have deadlines.
Have deadlines. I like that. Yeah.
Like create a schedule of everything that you've got to get accomplished.
Hey, you know a great tool for that? I just came to. Anybody know what a Gantt chart is? We use them in project management all the time, and it's spelled. And you can do G-A-N-T. chart. Okay. You know what it looks like? So, can y'all see? You can't see this on that, can you?
I can move this.
I usually do mine in Excel because I'm too cheap to buy Microsoft Project Management. You can actually do these in Excel. And so what you do is use a bar graph, but don't use the one with the bars going up, use the ones that go out to the side. And so you'll have, say down here is dates. Let's say the start, what's the start date for this thing? When it'll approximately?
November, just give, August 29th.
Okay, so August
Here you
29th.
go.
And then you might have a week out from that, would be September the
So that it will be 30
6th,
degrees on game day for the
September
people in the tent. You weren't in the tent.
something like that. Okay, and so you'll have different, we'll call them tasks. Task 1. And it may go to there. And then you may have a task 2 that can't start until here. And it goes out to there. And I'm just using generic tasks. You can come back over in your spreadsheet. So this is a chart in Excel. Y'all use Excel much? Some? If you don't know how to do this, go online and YouTube. Creating Gantt chart in Excel. They'll tell you exactly how to do it, and it's easy. Now, the beauty of this too is in your Excel spreadsheet over here, you'll have start dates, completion date targets, and how many days, and it'll create that for you then, and make this nice little, and then you can assign people's responsibilities. So I'm trying to get to where you were going with it. Who's responsible for these kind of target days? And notice something, that it's not a relay race. Some things you can't start until another one finishes because it's dependent. But those things that you can start, like, so that task 3 might actually not be required to start out there, and you can be working on these concurrently. So one team is doing task 1, another is doing task 3, and even another one is going to be working on task 2 and completing task 1. I mean, there's no right or wrong. It's just a way to visually show people. And again, that's something that you can put on one of those, I call them cloud drives. What do y'all call them? Shared Dropbox type things where everybody has access to it online. That's a good way to do that. Questions on that? You think that'd be helpful? And so, another way to think about this is start at the end, time-wise. So whatever the date out here is, that you got to have everything done by.
October 10.
What?
October 10.
October 10. Then you back into things. You may guess it, you say, how much time do you think it's going to take us to do this activity? And so somebody says, well, that's probably 2 weeks of the 6th. So figure out where it goes on this timeline, and that way you don't run into those constraints at the end of just not having enough time. That's the only way to get projects done on time in my book, is to do this and back into it. Start with the end date, start moving backwards. Everybody wants to start here and go this way, but that's really not the way to do it. You start out here. And if you can determine how much time you think it'll take. Those of you that have done these before, worked on the project, you'll know about what kind of time it takes. And give yourself more time in some areas than others. You know, I think your point was excellent. The quicker you can get something moving around and experimenting with that is huge, really valuable.
It also adds to the excitement because you're seeing something move, you know.
So you might put way up here in your task list to have a team working on, I'm going to call it propulsion, you know, locomotive or whatever, as its own little thing. How are we going to move our robot around? And so they work on that and build that part first before they start putting. Now you got to think about the constraints. You can't do that, you know, in a vacuum and not think about other elements of this thing, but the quicker you can get some platform going, it'll fit inside the requirements. Do that first. Do that first.
You remember 2 years ago when it was the trolley, you had no wheels. There was really no driving. It was just moving an arm or whatever you used to reach. So depending on the game, just get something moving that you can start practicing with, whether it's driving or arms or whatever.
There's another tool that I didn't bring any copies with me. It's called a product improvement checklist. I call it pickle list. And what it does is you go online and find these things on just Google product improvement checklist. And it'll give you ways to improve things. It'll give you constraints. In other words, if you put speed is constrained with what? You said it earlier. Weight, size, you know, there's lots of them that you compare, and then you look and see how people typically improve processes with that. How do you, you know, because you can search things. What's the most efficient way to reduce weight in design? What is the most efficient way to increase torque in design? See, or leverage, or whatever it is that you're trying to do, you can get to it now. You can find it. So look for those product improvement checklists online. They're really valuable and helpful, I think. Analytical evaluation alternatives. You know, do some actual calculations. Figure out why if it's got an arm on it and it failed, do some analysis. We call those post-mortems. Typically, because I mean it's something that didn't work, and so after the fact you're trying, was it because it just, physics won't allow it? In other words, there's too much weight on the end of this arm because of where the fulcrum is, that it's not going to work regardless if you use this material. Those are things you can calculate. So don't try it again. If the failure was because it's not going to work.
It's helpful to figure out the capacities of your motors before you try them and burn them up, because then you have to pay for a new one, even though it comes in your kit to begin with.
Yeah, those little electric motors, they have limits. That's a constraint. The amount of torque and load they can stand. The load is something you calculate. So get somebody that's a real good math and physics type person and really loves that kind of thing. Give that to them. Now, they may not be the people that are the most talkative in there, but they'll be really valuable if you can get somebody that likes that part of it. Find somebody like that on your team and put them on it, because that's going to be really valuable. Because it'll save you so much time. You calculate those things. Look, here's physics. That will not work. No way, no how. Not going to work. Can't. So that's really good. You know, methods of evaluation. You know, you've always got criteria about speed, durability. You know, different strategy. Maybe you want to be not in the challenge. You may want to be slower but more consistent. Because sometimes you give up things for speed, like durability. Thing flips over because you made it too light. Yeah, go fast, but it ain't going anywhere if it's up on its side. You can't do anything about it and you lost a round. So there's always trade-offs in design. And we talked a little bit about gaming strategy. You know, you can have different types of gaming strategy, the offensive or defensive. Most of the challenges that we've had the last few years lend themselves to offensive strategy, not as much on defense. Defense is kind of either trying to, you know, I think the example you gave is there's a community tool out there in the game field, and if you get to it first, then the other person, competing team can't. Then that strategy is defensive. You took it away from them, basically. Most offensive strategies are, do you want to score a lot of small points for doing a easy repetitive thing, or do you want to go for the big points by doing something that's really hard? And I've seen both strategies work for different teams. You know, it just depends on what you want to do, but you've got to think about that in your design. If you start thinking about your strategy, how you're going to score points, at the end, after you've already come up with a design, good luck with that, because it may not work out. You've got to consider them early. Document some safety training in your notebook. Just a page that says, all of our team members, not just this team, the notebook team, but all of them, went through an orientation to hand tool safety, personal eye protection, hearing protection, gloves, appropriate gloves. This is basic stuff, but you need to put it down and we know that you actually talk to people. We do want you to get through this without, getting hurt. And you're going to be using saws and soldering irons and all kinds of things that can be dangerous, but they're not if you just know what the hazard is with them. Protect yourself, And, don't get hero. Wear safety glasses. Wear, gloves when you're cutting things that have sharp edges with it. It's not a bad thing, but tell us what you did.
Pictures of yourself with
Yes.
goggles and gloves on.
Take snapshots with somebody with and it can be fun, make it fun. Put a hard hat on. You need a hard hat. Put it on. Along with safety glasses and hearing protection.
You can find that kind of stuff on Google, just
Well,
videos about it,
Yeah.
or if a parent works in an industry or something, get them to come in and do a little safety thing for you and document that. That's a good way
And
to do
guess
it.
what? They all have those safety things that they can bring a pair home or whatever. I mean, it's not like, because they literally have thousands of the ear protections or, so it's not going to be a real big problem on that. Support documentation, all of your, err on the side of taking more pictures than photographs than you think you'll need. Photograph everything. That's a good way to document the minutes along with actual written minutes. You can go ahead and take photographs, put your minutes out beside that. I think that's great. We don't see, those of us that judge these things, we actually like to see some photos in this too. Makes it better for us. So in addition to that, do some writing.
That being said, it's not a scrapbook for those girls or guys who like to scrapbook. It's not a scrapbook.
It's not a scrapbook.
But photos are good,
Photos
documenting your
sprinkled
process.
through with appropriate text that goes along with describing what was happening there is great. Yes.
If like you're judging it, would you rather give more points if it's got more pictures or more written document of what we did?
Yes. They've got to be, what's the right word? There needs to be a good balance and they have to be relevant. So if you can have a great picture, photograph, and the explanation or the verbiage beside it is not really directly relevant to what, and that's
Great
bad.
time was had by all. That's not it.
That's, that's not the thing, but if you had a photograph of your robot with a broken, axle on it, and then out by was, and you did that in the section that talked about, our first design led us to this because, and then explain why you think the failure happened. And then the learning from that was that we needed a different type of suspension under the but something that would be seen. Now that's great, because I can see, and now you've told me exactly what happened with that. But if it's just a photograph of a broken thing, and you just put out by there, bad night. That might have been true, but that's not enough for me to get something really valuable out of it. So be creative with how you photograph and explain things.
On the drawings, we want to see the drawings that you've made of your robot. However, how many of you guys recognize any of these?
Do y'all use them?
Do you
in
know
your
where they
notebooks?
came from?
They're
Yes.
freebies.
They came from the BEST website.
They're just hanging out there. You
And
can
it's
stick them in your notebook and
perfectly
get
all
points
right
for them.
to include these in your notebook, because these are all components that we're going to give you to use to build your robot. Okay? So don't overlook these drawings when you start to put drawings in your engineering notebook.
And more importantly, when I say you get points for them in your CAD drawing notebook, which is completely separate from your engineering notebook, you have to turn that, if you want to compete in CAD drawings, you're probably gonna do some CAD drawings, even some simple stick figure CAD drawings for your notebook, for your engineering notebook. Make copies of those, put them in a separate notebook, and submit it as a CAD drawing award submission. It has to be separate because they're judged separately, but why not? Because you've already put them in there, why not just make a copy and put them in another notebook and go ahead and compete in that part? But those are all freebies, and you get, I think, 5 to 15 points for each one of those. I can't remember exactly. It tells you on the score sheet how many you get for web, they're called web supplied CAD drawings, and that's what that's talking about, is all those. So,
Where can
and
we find
even,
those?
I'm sorry, what?
Where can we find those?
At the Big Best website, the bestinc.org, go to participant, file manager, team resources and training or something like that. Oh, he's gonna show it to you. Yeah, he'll get you there in a while.
A couple quick kind of takeaways I think might help. Okay, y'all tell me, how are you gonna do 10 minutes from your meeting?
Photos and writing down,
Hmm?
photos and noting it.
Okay, so those 2 minutes, kind of just how they, backing up, how are they useful? How can the minutes be useful to you?
Like, one time we had like a certain inch for a certain thing,
Mhm.
and we thought, oh, we need another same of that part, like a week later,
Mhm.
but we forgot the dimensions, so we went back and looked at it.
So if you document a few of those things, that's good. And usually it needs to be the same person that's doing that, so they'll be in the same place. So you can find it hard.
Having the sign.
Yes, I think that's important. Now, you can be creative with this too. How many of you have iPads or anything like a tablet device? Okay. Your phones, smartphones, iPhones, there are some free apps out there, Note Taker, that you can actually just speak to it. It captures the text. You just hit the thing. And so whoever it is, as soon as you get through, in addition to the kind of hand notes you might have taken down, you can just read the things back into it and then upload that note for that date. So it would be, this is Wednesday night, the whatever of August, and it's the first meeting of our engineering design team, and these are the following topics that we discussed. And you just boom, 1, 2, 3, 4, 5, and then upload those into wherever you're going to keep them so everybody has access. That's another way to do it. That's not the only way. You go look at it, have you a 3-ring binder, take handwritten notes, one person keep the binder and drop it in, perfectly acceptable. I'm just giving you some other options. I like to cheat and kind of read my notes after the thing, end of the thing without having to just type them out. That's it. So, questions? We've already covered that. Good organization, you just follow the templates that they pretty much what needs to be in there, the components. And make sure you don't have too many pages in there, that you put the things where they're supposed to be, like some things are appropriate to be in the, do we call it appendix, is that the, or is it?
The supporting documentation stuff at the back.
Yeah, I can't.
Yeah, it may be an appendix on there.
Yeah, I can't really.
I don't judge, so I don't pay attention.
But it, I've seen them before that it was hard to determine when I was trying to do an element of this thing. Is it in the supporting documents that I look for that, or is it here? Because it's not clear from their table of contents where I would go to look to find that out. So just organization for it. Spend some time with that. Any other questions? These are some typical pitfalls. You're going to have people, typically, that all of us are that way. Some people are a little pushy. Others are flies on the wall, and they're going to sit back. Flies on the wall. Flowers. What is it?
Wallflowers?
Wallflowers. That's what I was thinking. Something like that. Be cognizant on your team of all of those types of personalities. If you're prone, like I am, to vocally voice your opinion too often, taper that back, let other people's thoughts be heard. Just know that that happens. So there's a difference between participating and dominating and directing people. People don't like to be pushed. They want to have people that, you got to have leaders in the team to get everybody together. But the true thing of a leader is they want to get the most out of everybody around them. It's not about I'm the leader because I want my opinion to be the one that we go with. That's not a real leader. So whoever it is, if you've got those personalities, and if you're one that is not, you're on the other end of the spectrum, you know, find a way that you can get your input heard, whether that is that you have to think through things and write them down on yellow Post-it notes and put those ideas up at the back. That's okay too. Just figure it out the way so everybody can participate. Don't do things ad hoc on the fly. Have a plan before you start. Learn something every time. Don't plan, it's just going to cost you time. You know, you don't share responsibilities. You won't be able to do these concurrent things, and you'll have then a relay race. And you don't have enough time to have a relay race. I guarantee you, you just don't. You've got to have somebody assign these so that you can do it concurrently. So, questions? Here, questions. You never have questions. What did you learn?
Planning is important. Planning is important.
Planning is important. Very good takeaway. Detailed planning. That's also important. Documenting that detailed planning. Important. Okay. Steve, you want to start and share?
What I thought I'd do is show you the website, and Stephanie is passing out the score sheets that we use, so we'll look at that as well here in a minute. Let's see. Okay. If you'll put in bestinc.org in the address bar, Outlook or Firefox or whichever browser you happen to use, it's going to open this web page at best. Now there are several things here that you have access to that you can see. You can see some teasers from previous year's games. I think, Steph, aren't there videos? And I haven't tried to find those, but I think there are videos on here as well.
I think it's in the competition where it says yearbook. This will actually show you some of the games, and I don't know if it's videos, I think it's more pictures of them. So some of them don't have pictures, like the very first one I clicked on.
You have to get up here
There.
after they create
So,
the cameras.
Yeah, so that was back in, what was that, 2001 or something? That's one I had never seen. They're very different. Every year the game is really different. That was work 10. 2 years ago we had work 20, which was totally not like work 10. So, see, I mean, you can, and every, just with looking at the picture, you can never tell what the game is about. You have to see the rules and that kind of thing. And for those new teams who may not have seen anything about the game yet, did y'all show the teaser?
Yeah, we were playing it at the
Did you?
beginning.
Okay. So, that you got that much little 30-second of information so far, and that's it.
Okay. And to access any information that you want to, you'll just go to participants and file manager. And then public resources and training. Now you can go to the other folders. There are things there that might be of use to you, but if you come here, you can see some of the CAD models. There's going to be information on the software. There is some technical training in here that may help you with programming your controllers or designing the robot. And what? Um, The CAD models, these are the drawings that I showed you. You've got to be, you do have to have software that Stephanie assured me would work, and it didn't yet. So,
E-drawings didn't work?
so I haven't been able to. There's a reader that you need to download from the CAD software. And I either haven't downloaded the right one or I've got something set wrong on my computer to use it, so I have not figured that out yet. And this one's not set up either, so. That's the message that you'll get if you don't have the right software on your computer.
It's called eDrawings, and it's a free download. If you're using SolidWorks, I think you can download these anyway, or maybe any other CAD program, I'm not sure. But eDrawings is free, and it's easy to do just to be able to get the drawings and stick them in your notebook. You are not required to use a CAD program to do the drawings for your engineering notebook. It looks pretty, it's nice if you can, but you're not required to do that. If you just want to literally do hand drawings, you can. If you want to do stick drawings from Word, you know, if you can just create something and do that, you can. You're not required to do, you know, computer automated design drawings, but it's nice if you can. And these are free. And if you can just download the E-drawings, did you try that? E-drawings.
I downloaded Mode 30. You did have the 64.
Wow, that's weird.
So,
Then you can get some of these CAD drawings and use them.
but for a whole weekend, she had me going that it was me, that it was me, that it was me, and I have to admit, I am very technologically challenged. Okay.
So am I.
When I need CAD drawings at work, I send a hand sketch to the guy in Chattanooga that does CAD. So, but, okay, another thing that is here that we're going to take a look at in a minute. Whoops. Shoot, Stephanie, now I forgot what they are. The resources, the notebooks. Under team
Should be
resources.
under team resources, I would think. But maybe best award under,
Examples.
possibly.
Ah, there we go. There they are. They're under examples, and these are engineering notebooks that schools have agreed to allow best to post. Okay? Now, what I was going to ask you guys to do with me, ignore the school. Let's take your score sheet.
But you don't have
Yeah.
it. You may, they don't.
Oh, I thought I saw you passing that
I was
out. I'm
passing
sorry.
it some point.
Oh, you were just sorting.
I was sorting to make it easier to pass out.
And I'll say we, Mitch and I are two of the we, and then there's several other mice in our pockets that show up. We will go through, and for each engineering notebook, we go through every element on this score sheet. And it's my goal, and I think I've seen Mitch's and his are that way too. I try to give you comments. If I give you a score that is not pretty high, I try to tell you why. Okay? Because I want you to be able to improve. If you win here and you have the opportunity to go to Auburn,
That's good.
you can change your notebook between our competition and the best competition at Auburn. Okay? So take these, and they do get these score sheets, right?
Yes.
That, yeah, you do get all the
You get
all the comments from the score sheets.
You get the best award score sheets, which is project engineering notebook, marketing presentation, team exhibit, and spirit and sportsmanship. You get those back for sure, and sometimes you get the others back. It just depends.
And And please accept this as constructive criticism. We don't intend for it to be harsh. I've seen some that the way they were written, it would be very easy to take it as harsh criticism. It's our intent, though, to help you make your notebook better. That's what we, the judges, are trying to help you do by going through these. Okay, so first, we want to see evidence. And I'm not going to go through every step here. I just wanted to go through a few to show you with one example what we would look for. Evidence that the engineering process was used effectively. So we will take we will go into your engineering notebook and we're going to look to see if you used the process. I should have marked these up. I'm sorry I didn't. I didn't think about that until just now. If I had marked these up with my score, this would have gone faster. Here they analyzed points for the task. They estimated what it would take to get the points. They decided that opening the doors to the cockroaches and flies to activate the tiebreaker switch was important. They decided to get a red fly first. So they've got a lot of strategy so far, but do you see much about how they engineered their robot yet? Okay. And that's what we would look for, or I would, for that first item. I'd be looking for ways that you use the engineering process. How did you document the decisions that you made? How did you document why your robot was constructed the way that it was? Those are the kinds of things we're going to look for. Let's come down here to, let's see if they do any offensive and defensive evaluation. They've got a really nice table here showing the different strategies that they could use. And as you look through there, these are primarily offensive, as I see them right now, without digging into them a little bit deeper. And in this particular game, there really wasn't much that you could do defensively, if I remember right.
They may have in their table of contents something about their office. A lot of people do that in their table. And again, that's make it easy for the judges. You got the score sheet, so I would correlate the score sheet to my table of contents where the judge can easily go, table of contents, I'm looking for something on defensive strategy.
And title your section by the name of what's on the score sheet, so your judge knows exactly what he's looking
Where
at.
to go
You know?
from?
Yeah.
Yep.
Make it easy for the judges. They have a hard
Here
night
they have
judging
all
all these notebooks. Yeah, that's fine. Thank
They have a
you.
whole section on offensive and defensive evaluation, so let's go see what they have. Page 23. Don't want to make you see soon.
Too late.
There we go. So they've clearly documented, they would score really well. We would look at some of the content in there as we go, but it looks to me like they probably would have scored very well because it looks like they've done a lot of analysis on what were the offensive and defensive strategies that they could use in the game. Okay? And like Mitch said, you need to make it easy on your judges to find things. So that we can go through yours as quickly as possible.
You're disrupting the class lead.
That's what my teacher always said.
Ex-educators are pretty good at that, you know?
For those who don't know, Mr. Brownell no longer is the sponsor of the Russellville team. He now works with Amsty.
I missed the Paris trip by that much. So, yep. If y'all know where the Russell team can get a lot of money so we can go to Paris, let us know.
Did your teachers tell you that? Their robot team also has members on their rocket team, and their rocket team won nationally, and now they get a free trip to Paris for all the students that are on their team.
So, it's free to the team and the sponsors, who I'm not one of. They get to go for free, and then we got to try and get their parents there. That's what we're doing. So, but I am going to offer a class sometime after after our competition. What day is the competition?
October
the
10.
10. So after that sometime, we'll offer a class, and I'll tell Ms. Stephanie, and she can send out stuff to your best person, your sponsor, and they can bring you and help you start a team so that you can launch rockets and go to Paris too. Next year will be in London though, so guess you get there. I'm sorry.
Goodbye.
Oh, they hear his word.
No, they got a tunnel. They got a tunnel. Anyway, y'all learn about engineering.
Okay, we said that safety is very important, and this team apparently thought so too, because they've dedicated a whole section of their notebook to just safety. So let's go look at page 25 at the safety. They've got a pretty good write-up. Their fabricators had to pass this safety test. We won't try to read all that, but you know, that's a very good thing to do. Make sure people are familiar with the hazard.
And see, what they did that's good there, in my opinion, they gave evidence. They just didn't write this up. That's an actual form that they scanned and inserted in. So I could see, they didn't just write that they did that. Somebody actually took some tests and they gave an example of it. Very helpful in grading, because I'm always, you know, hey, did you really do that, or did you put it in there in writing?
Most industrial accidents, and I worked in electric power plant for 30 of my 35 years with TVA. Most industrial accidents occur because either the hazard was not identified before people started work, or people did not take the right steps to keep from getting hurt by that hazard. A big one is pinch points, where you know, two things are swinging close together and you get caught between them. Saws tend to make fingers shorter. You know, a good example, my mother at 78 years old was snow blowing, mind you, which she probably shouldn't have been doing to begin with. The snow blower plugged up. She reached up and slapped the snow to clear the chute, and the snow, instead of blowing out of the machine, fell back into it, and her glove was wet and stuck to the snow. And she now has two fingers that are shorter than they used to be. So you need to look for those things, and that needs to be part of your safety evaluation. Always think, what if? Mitch mentioned 5 whys, and you know, what if can go the same route. You know, what if my hand gets into that blade? It will feel real good. So, you know, safety needs to really be at the forefront with you so that no one is injured in the process. Okay, well they've done a pretty good job with safety. This probably would have rated fairly high. We don't really have rules, or rules is not the right thing to say, I don't think. We don't really have, any rules for how many points teams would give. You know, what is a 25? So each of us will grade what we think is appropriately, and then those grades are tallied so that everyone is we hope everyone is being graded fairly. Well, no, not hope. We try very, very hard to ensure that everyone is being graded fairly. So
Your notebook is judged by four different judges, so you might have a hard judge, but more likely if you do, you'd also have an easier judge, so it kind of balances out. You know. And your notebooks are due the Tuesday before the game on Saturday, so they're actually due on October the 6th, is that right? 10/6, yeah, on the 6th. You can hand deliver them for those that are close around, that's easy enough, but I know some of you are way far away, Meek, and the Bankhead, I think, is our farthest and our furthest. But you can mail them, you can FedEx them, you can UPS them, you can overnight them, whatever, you know, works for you. But if you get it done in enough time, you don't have to physically come and deliver it. But the instructions for how to do that are in that longer document I gave you. But just know this too, that even by Tuesday, if you're hand delivered at 5 o'clock on Tuesday, more than likely your team is still working on your robot. So your notebook is not going to be the actual final project for the most part. It's the design concept, right? I mean, because you can't put a final version specific in there because they're probably still working on it until the night before the competition.
The most important thing is that you follow the process.
Right.
If you've documented and shown in the notebook that you follow the process, we know that there may be last minute iterations that didn't make it in the notebook that's actually in the design. Okay, that happens. But we don't grade for that. We grade, is the content here? Did they follow the process? Did they document the process that they followed? That's
Yeah.
it.
Yeah,
The judges
Tuesday-
don't know what your final robot actually looks like because you're not turning in your robot, you're turning in your notebook. So
The
just
way
make
I
sure
look
that
at
that
it
process is followed correctly.
is what you turn in to me on Tuesday is your final robot at 5 o'clock on Tuesday. And between Tuesday and Saturday, you are allowed to make process improvements.
And if you go to
So-
South's Best, if your team wins and gets to go to South's Best, you can actually make improvements before you go to South's Best. You have to turn in your notebook early, but you can still be improving your robot and doing something completely different
And
if you go to
really
South's
embrace
Best.
this process, even though you got the final notebook to us on that Tuesday, do you stop doing your minutes and documentation, even though they don't go in it? No, it's part of learning. It's part of learning. You want it for next year. What you may have learned in that last 2 or 3 days might have been huge. And if you didn't document it for yourself, then it's a waste.
So that's basically how we would grade your notebook and what we would look through. So since you guys have the score sheet, do you see anything there that you have questions about? Yes.
Last year when we got back the sheets of when they scored our notebook, one of them was like, they counted off 2 points because of, I don't remember the name of it, but the preference of the judge. Why does that matter? If like one judge has a preference of this, so he minus 2 points. There was one where I didn't really understand.
That's the hard
Did you
judge.
understand that?
Just blame it on the hard judge. It was Mitch.
Yeah.
Did they didn't give you a note?
No, they just said just because.
See, that's irritating to me. We ask them and beg them and plead with them, please, if you count a point off even, tell them why. Tell them why they didn't get a perfect score. Even if it just didn't look right, it wasn't about, I don't know, whatever. You know, like I said, I don't judge, so I don't even know. But tell them why. And when our judges don't, there's no way to go back and get that information because they've looked at so many, you know, after they're gone, they don't know. But
And sometimes they meet the criteria, and, you know, that's what I'm looking for. I don't go back and try to, if there's 2 that I grade, and they're excellent notebooks, they've hit every point on here that's required, I don't go back and try to say, you know what, I think there should be a difference, there shouldn't be a tie, and I'm gonna go back in and count you off. No, that's not what this is about. This is about giving you feedback, that you understand documentation of the engineering design process, You did a good job doing it, you hit the elements, you gotta get 100 points from me if you did those things. If you didn't do something, for example, let's say you didn't document your safety training, you wrote up something about that, you know, we believe safety is very important, blah, 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 but no supporting documents like we saw in that other one, then I'm going to give you some points off that say lack of support documentation to the safety program in your notebook. You know, and that's enough for you to learn over. You can't off because, you know, I didn't document performance on this thing, or evidence, I would call it. That's what I did, everybody.
One other difference that's on this score sheet this year, the team demographics form right there, 15 points, is no longer going to be in the notebook, and it's not going to be points as a part of the notebook. You're going to turn that in. You'll just probably just do it online like you had to do anyway, and then had to do this too. But it's just going to be online, I think, this year. If not, if you have to do a paper copy, it will be turned in at the compliance table with Mr. Steve. But I don't think we're going to have to do that. So that 15 points will be spread somewhere else, but that's Big Best makes that decision. So I don't know where those points will go, but they'll probably just be spread with some of the important things there.
And that's why I said up front, this form may not be the form that we use. In fact, we know
It's
it won't be
definitely
the form that we use. We already know there's that change, and there probably will be a few others. And I did the same thing that Mitch does. I try, if I don't give you 25 points, I try to tell you why. What was it that I thought needed improvement? And I think most of the judges do that because this is a learning opportunity. This isn't the final exam. It's not that you're going to graduate. We're simply, we want to help you improve next year. That's the whole idea. Or improve so you do even better at Auburn. So. Any questions about the scoring? Yes.
Is it preferable to have the notebook in the order that's on the score sheet, or can it be in any order?
Okay.
Repeat
The question was, is it preferred to have the notebook in the order that the score sheet is written? From a judging standpoint, it will be much easier to grade the notebook if it is. If it's not in the same order, you need to make sure that it's easy for the judges to find the information. I graded one last year that I went through and I didn't find something, and I scored them very low on it. 2 notebooks later, a different school had the same issue, and I thought, wait a minute. So I went back and dug through the notebook, and then I found it. Sure enough, went back to the first school, and they had also hidden it from me. So I don't take responsibility for low scores if you hide things from me, okay? So just make sure, if you're not going to put it in this order, make sure that your table of contents will help the judge get to the information. Any other questions? Other than she's ready to go home. Okay, I have a homework assignment. It won't be graded.
That means they won't do it.
But I know who's here. I just don't remember your name. If you would please, if you have any comments, please send them to Stephanie. We want to make this training better for you. So if you've got anything that we didn't cover that you think we should have, or anything that we could have covered better, you know, please send those to Stephanie, and I'll tell her when she comes back, she can take your name off the email and send that information to us, and then we can make this training better for you and those that follow you. So that's all that I had to cover today. Good luck on the competition. I think you're really going to enjoy the game this year, and It's going to be a little bit of a challenge, but I believe you're going to enjoy it. Go into it anticipating having fun, okay? Thanks.